And here we go. Today we get to the more challenging problems. Hopefully some of you were able to work through some of your assignment yesterday. Today, these problems are definitely not as intuitive. The first problem, tangent squared over secant minus 1. A lot of people think of this as tangent squared of theta over tangent of theta. They say, well, secant minus 1 must be tangent because secant squared minus 1 is tangent squared, right? If you look at that sheet of notes that was provided to you, Hannah's like, what the heck are you guys talking about right now? If you look at this note, you see that tangent squared is equal to secant squared minus 1. Well, it's not true that tangent of x is equal to secant of x minus 1. It does not work out like that at all. You can't simply make that substitution. And so for this problem, I'm actually going to make a substitution that might make some of you somewhat uncomfortable. Hopefully you can come to terms with it and accept it. Here's the substitution. I'm going to take tangent squared, and I'm going to actually express it as secant squared of theta minus 1 over secant of theta minus 1. So instead of dealing with the bottom, I dealt with the top. Well, why would I do that? Because I noticed something about the top. X squared minus 9, 4 minus y squared. Those are a difference of two squares, aren't they? They therefore factor. Just like secant squared minus 1 is also the difference of two squares. And it will factor to secant of theta minus 1 and secant of theta plus 1. All over secant of theta minus 1. What happens? Secant of theta minus 1, those cancel, leaving me with secant of theta plus 1. The next one's going to follow very similarly. I'm not going to deal with the cosine of theta plus 1. Does anybody know what I'm going to put in place of sine squared? I'm going to put 1 minus cosine squared. Awesome. 1 minus cosine squared. I hope that that factors. Does it factor? What does it factor to? Oh, Alex leaves and we all go quiet. Not you, Alex. Other Alex. Yep. 1 plus cosine of theta. 1 minus cosine of theta. You can see that in this situation, cosine of theta plus 1 and 1 plus cosine of theta, they are the same. They cancel, leaving me with 1 over 1 minus cosine of theta. One thing that you've learned between yesterday and today is that squareds are great because you can substitute things in for them. I don't have a squared for letter C. Is there something I could do to create a squared? How? Distribute. I'll take secant times secant. I get secant squared of theta. And then I have secant times cosine. I wish I knew what secant times cosine was. Excellent. Only in pretend world. You see, secant times cosine, what's the relationship between secant and cosine? They are reciprocals, right? What happens when you multiply reciprocals? What are you left with? 1. So secant times cosine is in fact 1. So we have secant squared minus 1. I wish I knew what secant squared minus 1 was. Tangent squared. I'm sorry, Hannah. This is going to be painful. So, same thing here. Let's distribute. Sine times sine. I have sine squared of theta. Trying to bring back this point again. Sine and cosecant, what's the relationship between those two? They are reciprocals. If you multiply reciprocals, you get 1. So 1 cosine squared. And only if I knew what sine squared plus cosine squared was. It's 1. Remember the most important formula I told you to know. What's the capital of the United States of America? Washington, D.C. And sine squared plus cosine squared is 1. St. Paul is the capital of Minnesota. Thank you. Olympia. What would you like to do for letter E? Columbus. What would you like to do for letter E? Yeah, let's multiply it out. FOIL. See what happens. I mean, if we don't know what to do, we should try something, right? It's kind of like a puzzle. Sometimes you gotta try a piece, see if it fits. If it doesn't, you just move along. So 1 times 1 is 1. 1 times cosine is positive cosine. 1 times negative cosine is negative cosine. And then negative cosine times cosine is negative cosine squared. Well, what happens? Cosines are gone. I get 1 minus cosine squared. You see, we knew, I know you guys knew, that these were going to cancel anyway, right? Because you said, hey, these are conjugates. Anytime you multiply conjugates, the middle's canceled, right? That's the way it goes. And we're left with this piece. I don't really know what to do with that, but yeah, it is just sine squared. Isn't that convenient? F, those look like conjugates as well, don't they? If you multiply, what are you going to get? Tangent squared, the middles will cancel, and then minus secant squared. Is that a formula on your sheet? What does it say? Does it? It says secant squared minus tangent squared is 1. I mean, they're flipped, aren't they? So how about we factor out a -1, says my man, Mr. Henchy. Take out a -1, you're left with secant squared of theta minus tangent squared of theta. What is secant squared minus tangent squared? If you don't know, then you should for sure have the sheet out in front of you so you can reference it. And when you have it out, you'll see that secant squared minus tangent squared is in fact 1. So the answer then is -1. Letter G, are those conjugates? Yeah, so the middles are going to cancel. What are you going to get first? So with an F rhymes with or. Or secant squared of theta minus 4. Now, I don't have anything on my sheet that has a 4 in it. Factor it out. 4 times secant squared of theta minus 1. If only I knew what secant squared theta minus 1 was. Well, that's tangent squared, so I end up with 4 tangent squared. Now you feel like you're rolling. You're like, Mr. Gans, this you told me it was gonna be bad, but it's really not that bad. Let's get just a little bit more complicated here. What's that? Yeah, it does get a little bit worse. Okay, it's a little bit more challenging. Sometimes, the goal is here is you see how you're able to create squares, right, by multiplying. That's one of those strategies. So we have like change to sine and cosine. We have like substitute things in. We have factoring. We have multiplying. Sometimes you have to deal with fractions in order to create a square. And I'll show you how that works. In this situation, I'm going to write as cosine of theta over 1 times tangent I'm going to write as sine of theta over cosine of theta. Plus cotangent I'll rewrite as cosine of theta over sine of theta times cosine of theta over 1. Now, can somebody tell me, is this a valiant effort here? Is this worth my time? Do I come out with anything good? You're not going to see the answer right away. But if I try that, what happens? Okay, the cosines cancel. That seems like a decent thing, but there's something else that happens that's really good. I get a cosine squared. Like, that makes me happy. I like to get squares. And so I have sine of theta over 1 plus cosine squared of theta over sine of theta. And now I pause because now now I'm just kind of looking at it, being like, holy cow, what do I do next? And I recognize I got this cosine squared. If I were to combine these fractions together, I have to find what? Common denominators. What's the common denominator? And if I multiply top and bottom by sine, is that a good thing? Why? Because I get a, so all of a sudden I get sine squared of theta plus cosine squared of theta over what's in the denominator? And now only if we knew what sine squared plus cosine squared was. And 1 over sine is cosecant. Go get your brain food. Come on back smarter. We will roll. How this guy goes right here. So I change it to sine squared of theta over cosine of theta plus cosine of theta over 1. Right? Because it's one, secant is 1 over cosine, right? So then what do I do now? Common denominator, says Kayla super quietly, but I have great hearing. Okay, so I multiply top and bottom by cosine theta. Why is that a good idea? Because I come up with a cosine squared. That's all over cosine. What is sine squared plus cosine squared? 1. So I get 1 over cosine, which is secant. Good. 3 more. We'll call it a day here. What would you do for letter J? I'm not gonna give you any thoughts. What would you do? Something with fractions? Okay. So what do you want me to do? 1 minus cosine theta over 1 times sine of theta over 1 times sine of theta over cosine theta. Okay. So, it's like, hey, you don't know what to do, just try something. Is that going to help us at all? How? Excellent. So you can see the cosines cancel. 1 minus sine squared. What's 1 minus sine squared? Cosine squared. And our last 2 examples. This is where it gets just a little bit trickier. We are going to create one fraction in both situations. Finding common denominators, working towards a fraction is an important step. I multiply top and bottom by sine of x plus 1 over sine of x plus 1. The other side I multiply by cosecant of x plus 1, cosecant of x plus 1. So as we look at this, cosecant of x plus 1 times 1 is just cosecant of x plus 1. And I'm going to have that plus sign. Sine of x plus 1 times 1 is just sine of x plus 1. All over. Does everybody agree in the denominator you have cosecant of x plus 1 times sine of x plus 1? That just cancels off, right? Why? Yeah, there's the addition sign. So a lot of people wanted to cancel those off in previous hours. Jackson has shown his excellent mathematics today. 3 plus 4 over 3 times 4. You can't just cancel those off, can you? That's like 7 over 12. It's definitely not 1. Is everybody agreed? So we tried finding common denominators, and I always like to leave the bottom factored until I really don't have any more options. So let's multiply the bottom out. But first, what can we combine in the top? What does combine? 1 and 1 make 2. So we get 2 plus cosecant of x plus sine of x. And then bottom, what is cosecant times sine? What's the relationship between cosecant and sine? They're reciprocals. If you multiply reciprocals, you get 1. So cosecant times sine is 1. Then cosecant times 1 is cosecant. 1 times sine is sine. And 1 times 1 is 1. But a plus 1, wouldn't that just make this 2? So in that situation, they are the same. Very rare does that ever come out, but they are the same. So these, in fact, cancel. We're doing 1. And just to be clear, it's not that the cosecants cancel, the sines cancel, and the 2's cancel. It's that that cancels with that. That divided by itself is 1. You notice that you maybe could like just walk up to the test and write down like say sine of x or tangent squared of x or 1. You got a decent shot at getting the problem right, don't you? For that, you'll be awarded 0 points. So your work must support your answer. Probably not, no. Extra credit, I definitely want to see your work too. Question? All of your answer. Here we go. Last one. Sine of x over 1 plus cosine of x plus cosine of x over sine of x. All I did was just change the cotangent so that I could have 2 fractions. Now I have 2 fractions, and again, my kind of method that I'm using is making 1 fraction by finding common denominators. So what would be the common denominator? What would I multiply the top and bottom of this side by? Yeah, sine of x. Is that a good idea? Why? Because it will get me a sine squared. I like that. What would I multiply top and bottom of this side by? 1 plus cosine of x. We have a lot of people gone today. We haven't buried a secret word in the video. Last time we did, Griffin just told Henchy anyway. So if you guys can keep your mouths shut, then I'd like to bury a word in here. What's the keyword for the day? Michaela, we'll go to Michaela. What would you like? Keyword. You're gonna bury it in the video. If they say it, they get a free Debbie snack. Pomegranate is what we're going for. So, and if any of you putzes tell somebody the answer, very good. Put your stupid phone away. We multiply. I get sine squared of x plus. Note that the cosine here must multiply both of those. So I have cosine of x times 1 is cosine of x. And I have cosine of x times cosine of x is cosine squared of x. Over sine of x times 1 plus cosine of x. Again, I don't like to multiply the denominator out. Question. It is. Sine squared is 1 minus cosine squared. Yep, so you could insert that, but there's something else that you can do as well. You could take out a cosine from these two, but it's not there. There's something that you want to see. It's staring you right in the face. The capital of the United States of America is Washington, D.C. Sine squared plus cosine squared is 1. See it? It's right there. That's 1. So we get 1 plus cosine of x is what's in the numerator, and the denominator is sine of x times 1 plus cosine of x. And what happens there? Top, bottom cancel. I get 1 over sine, which is cosecant. I mean, you don't have to love it. but I sure hope you can appreciate it. It's beautiful. I mean, hey, no, 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 no. Now you're judging me, okay? Like, guess what do you know about beauty? You're uglier than a raccoon that got dumped into Henshi's freezer. Here we go. So, so, look at what we started out with, and predicting that the result is cosecant. That's kind of it's kind of nifty there, huh? Yeah. You're now ready to complete your entire assignment. I'm not going to give you a new one. I am going to print off some copies of the additional assignment I gave in case people want extra practice. You have the rest of the time to work. I need to make a few copies. There you go. Good work today. Pomegranate.